पापा
Okay, we are starting the class. Sarayu, you are there?
Yes, sir.
Okay, yesterday we did this factor affecting friction. So first factor is type of material that the two body is made up of. Let's say one body is leather and one body is rubber. So the sticking problem will be more. You will have more friction. That's why the basketball is made in such a way. So how the two material are there, that is going to decide more about the friction. If both are leather, the friction will be different. If one is rubber and one is leather, the friction will be different. The second point is condition of the rubbing surface. How the condition is, the surface, where the contact is, whether it is a rough or a smooth surface. Like in cricket, you can see bowling pitches are there, or we can say it is pitch for the fast bowler. Pitch for the fast bowler. The next was the force pressing the body together. If one body is heavier, it will have more friction. So how you will get the resultant force back when it is pressing downward? That's how it is going to give you the resultant in forward direction. Okay. So when two bodies, this is not the contact surface area is important, but the force or the weight, we can say, the body pressing together. Okay, you got this?
Yes, sir.
And the last one is the relative motion between the two bodies. How both the bodies, if both the bodies are moving in opposite direction, or whether one is static, or both are moving in the same direction. So the relative action, that is important. At the moment of start, we can say if one body is at static, it will be greater. The friction will be greater. That is static friction. Then come the sliding. And then come the rolling. So what is the relative motion between them? That is very important. Here in note it is written that the weight of the body is assumed to an imaginary point of the body CD. The force of friction does not depend on the area of contact surface. Like this in this, the area of surface contact with the sand is more compare, but we are assuming that it is working only on the center of gravity, that is on the CG. Okay, you know what is CG? Center of gravity.
yes sir.
There's one point where all the masses, we can say, is counterbalance, or where all the force become zero. All the positive and negative force, they are zero. Or we can say the weight of the body. This is a point where weight of the body can be balanced. Okay.
Yes sir.
Yes, sir.
The situation where great amount of friction is required. We here the situation where we need more friction so that movement can take place. We don't need less, we need more. Just like track running, we need more friction because of the surface also, and with the shoes also you're wearing. High jump, you're wearing a shoes where spikes are at both the end of the shoes. That is front also and behind also. Football shoes to maintain the balance. Same in hockey also, because in hockey, what is there? Water is there on the surface, so we need a good amount of shoes to overcome that less friction thing. Because in hockey, we put water so that less friction is there for the ball. But that means that surface is now nearly frictionless. We can say very less friction it is giving. So we need a good shoes so that we can maintain dynamic balance. You can see grove on the ball like in golf ball. Why it is there? The more friction will be there in the golf ball will go more further. If the ball is smooth like table tennis, it won't go. Then the basketball court. We need more friction just to take the jump and all. The good amount of friction is required. Now next is the situation where we need less amount of friction. Like in skiing, we need less friction. Why? Why we need? Because the movement can take place faster. In swimming, we need less friction. We are wearing all the caps, we are shaving the hair because we need less friction there. Aerodynamic shape in javelin, or we can say aerodynamic shape in bike, car. So you must have seen the cyclist helmet. You've seen the cyclist wearing helmet,
Yes, sir.
how they are, how they are.
Aerodynamic shape.
Okay, let me show you the cyclist helmet. You know how they are wearing? Why they are wearing? Because the head should not give hot friction. These are helmet for what? To save you from the injury. Which one is a better one? You'll see this.
Yes, sir.
Yes, sir.
Here you can see this shape. That is the shape is only because for the aerodynamic shape we need. I'll copy this image and paste it over here so that for next I can use this figure. Okay, you can see this now.
Yes, sir.
We can see that how it is. Okay, so this shape, which you can see now, is aerodynamic. In some figure, it is going more because all the resistance or the drag or the force that is coming, friction force, it has to be go in such a way that it should not hinder the movement. You can see the upper body what he is wearing, the t-shirt, it is giving you lesser force because it is not a loose shirt. Because if it will be a loose shirt, it will going to give you more friction. So for this indoor here, you can see this figure also. In this figure also. Okay. So these are the example. Hockey ground. Hockey ground is what? Giving you less friction. Now let's move further. We'll see this video later. Now let's see what is this friction angle, or we can say coefficient of static friction. Let's say one body is, this box is on a plane, and let's see we are shifting this body so to find the coefficient of static friction. So we started this body to move upward. At this point, at this angle, the body is starting sliding. Okay, you got this? Okay? ये समझ में आया?
Yes, sir. Yes, sir.
This is the body resting on this ground. We started moving upward. Why? Why? To find this angle, at what angle this body is going to slide downward. Okay? Various force act on a body, that is F11, here you can see, is equal to the force of static friction is equal to mg sine theta component, as inclination angle is greater than certain value. So what is mg here? Mg is the weight of body at vertically downward, mg. Okay, that is mass into gravity. Okay, mg. Mg is resolved into two rectangular component, that is mg sine theta act where parallel and mg cos theta act perpendicular to the inclined plane. So mg sine theta, how it is acting? Parallel. I'll write here parallel. And mg cos theta. See, where is mg sine theta? It is acting parallel. And how the mg cos theta is working? Perpendicular. Okay? You got this? ये समझ में आया?
Yes, sir.
हाँ, एक cos थीटा है, एक sin थीटा है. तो जो परपेंडिकुलर एक्ट कर रहा है वो cos थीटा है, जो पैरेलल कर रहा है वो sin थीटा है. okay, to the inclined plane. Now mg cos theta and mg sin theta balance the normal, that is N, and the frictional force respectively. This is the normal force and this is the frictional force, which will act opposite. Because the movement is taking place in this direction, it will act in the opposite direction. Okay, you got this? Now
Yes.
let's see F perpendicular is equal to mg sin theta. By increasing the angle, we can say F parallel is also increasing, but it increased till the limiting value. As we are going upward, so it will increase till the limiting value. F parallel is equal to mu n, where mu is the coefficient of static friction and n is the normal friction. So this mu n, in this mu is what? Coefficient of static friction, n is the normal force. At this juncture, as the body started sliding, it will be known as friction angle. Let theta 0 be the maximum incline for which book is stationary. Then mu n is equal to mg sin theta. Instead of theta, what we are writing here? Theta 0, because it is the maximum angle. Since n is equal to m cos theta, this m is what? N, mg cos theta is equal to, then mu is equal to mg cos, instead of this n value, we are putting mg cos theta 0. So mu is equal to mg cos theta at 0 is equal to mg sin theta. So we can say mu is equal to tan theta 0. This theta 0 is the angle of response, or we can say friction angle for these two surfaces. Whatever these two surfaces are made, it will be known as friction angle for these two surfaces. Now let me ask you anything you didn't understand in this. हेलो,
यस सर.
ये समझ में आया कि ये वैल्यू यहाँ पुट करिए.
यस सर.
ओके,
Yes, sir.
so this is basically the angle, that is at this point, reaching on this angle, the body will start sliding. So it will be known as friction angle. So this is our friction chapter is finished. I am starting the one more one, pressure. So I'll give you today the introduction of that. Okay, pressure. You must have studied since very small class what is pressure. So pressure is what? Force per unit area over which the forces act. That means pressure is equal to force divided by the area. This is the force and this is the area. Okay? Pressure is defined as force distributed over a given area. That is P is equal to F upon A. This is the force and the area is there. Moving further, what is the unit of pressure now? We can say unit of pressure of force divided by the area. So common is N per square centimeter. This N is what? Newton. Newton per centimeter square. And you must have seen the Pascal. हवा भराने जाते हो तो P लिखा रहता है. When you go for the bike or car to fill the air, that time it is written Pascal. Okay, so in metric system it is Newton, that is N, divided by centimeter square and Pascal. So what is 1 Pascal? 1 Pascal represent 1 Newton per square meter. That is N upon M square. It is centimeter. Here it is meter square. Okay. So in both the system, metric system, we can say it will be Newton. You can find it there. Or we can say Newton per centimeter square also. In English metric system, the common unit of pressure is pound per square inch. कहीं कहीं pound भी लिखा रहता है. So there are all the three, that centimeter, meter and inch, and sometimes it is written in pound. So it is depend on the measurement how you are going to measure. Okay. अगर गोल्ड लेने जाते तो हम काय में लेते गोल्ड?
कैरेट
हैं?
कैरेट
नहीं, वो तो उसकी क्वालिटी है. वेट की बात
ग्राम ग्राम
ग्राम
ग्राम में लेते हैं. और सब्जी लेने जाते तो
केजी
हाँ, इट इज समथिंग लाइक दिस ओनली. केक लेने जाते तो पाउंड, है ना. केक काय में लेते हैं? पाउंड में,
यस सर आपने
है
बताया.
ना. तो ये LB इज द पाउंड. ओके. दिस इज PSI, पाउंड पर स्क्वायर इंच. ओके. तो ये यूनिट अगर PSI दिखेगा तो ये समझ लेना इट इज पाउंड per square inch. Now moving further, you know little about anatomy.
यस सर.
Okay, let me give you the example. Our heart is basically a pump. हमारा हार्ट क्या है? बेसिकली एक पंप है. तुम्हारे घर में पंप लगा है, you will have pump in your house to pull the water.
यस सर.
So this is also a pump only. Now let's see, this blue color is deoxygenated blood, or we can say the blood. Oh, mic बंद करते हैं. Or we can say the blood that is used by the body. So blue color is the deoxygenated blood. We can say इसके अंदर ऑक्सीजन नहीं है, कार्बन डाइऑक्साइड है. This red portion is having the oxygen. Now what is heart doing? Whenever the heart has to pump pure blood, और इसको इम्प्योर भी बोलते हैं. अब इम्प्योर का यहाँ मतलब है ऑक्सीजन और कार्बन डाइऑक्साइड. तो लाल जो खून है, रेड वन इज विथ ऑक्सीजन. So from here the heart pumps the blood. This is through aorta, and the blood goes to different part of the body. One part is going above the heart and one is going below the heart. हार्ट के ऊपर भी जा रहा है, हार्ट के नीचे भी जा रहा है. एक एग्जांपल, हार्ट के नीचे गया और ये पैरों में गया और हमने यहाँ उस ब्लड को यूज कर लिया, हम दौड़ रहे हैं. और वी कैन से द ब्लड इज गोइंग टुवर्ड्स द अपर पार्ट टू द ब्रेन. ब्रेन इज यूजिंग दैट ऑक्सीजन. Now what is happening? After using, the oxygen is used up. Now carbon dioxide is mixed in that. So this is where the blood is coming down, and from your legs after using, it will go up. Now the problem is when it is going up, due to gravity, it can come down. But when it is going to your legs, how that blood is coming up? This is the question for you. How the blood is coming up to the heart? Hmm? Anyone?
So veins carry blood towards the heart from the
Hmm?
body.
How?
So veins carry blood towards the heart from the body.
वो तो मेरे को समझ में आ गया, but how it is going to come up? ये ऊपर कैसे आ रहा है? नीचे तो चला जाएगा ना, ग्रेविटी के कारण. ऊपर कैसे आएगा?
सर वो
So
प्रेशर जो
outside, the heart is pushing the blood, so the other side it is automatically going there.
Hari, repeat please.
So one side the heart is pumping the blood, sir, so it is automatically pushing that blood towards the heart.
Little bit close. Little bit close.
सर
हाँ.
हार्ट कंटिन्यूस पंप करता रहता है तो सर उसके प्रेशर की वजह से सर ब्लड मूव करता रहता है पूरी बॉडी में.
ये तो हरी ने भी बोला. ओके, आई लेट यू नो. जब तुमको होटल में जाते हो या कहीं जाते हो और तुम जूस पीना है ग्लास से, तो तुमको स्ट्रॉ ला के देते हैं. तो स्ट्रॉ में क्या करते हो तुम? मुंह में लगाया तो आ जाता क्या अपने आप? व्हाट यू हैव टू डू? You have to pull it up. So you suck it and you create a difference of pressure, because our topic is pressure. So that difference in pressure pull the blood up. Like in, I told you, no, it is like pumping. हमारे घर में पानी नहीं आता तो हम पंप लगा के क्यों खींच लेते हैं? So it is that the pressure difference due to the pressure difference. हम blood pressure जब नापते हैं अपने हाथ में, that जहाँ भी हाथ में नापते हैं वहाँ ब्लड प्रेशर एक उसका वैल्यू आना चाहिए. वैल्यू मालूम है कितनी है? वैल्यू मालूम है? एनीवन? ब्लड प्रेशर? ओके, वैल्यू है 120 जो नॉर्मल मान लेते हैं, और नीचे की वैल्यू 80. तो जब हार्ट पंप करता है ब्लड, उस समय वो वैल्यू 120 होती, मैक्सिमम प्रेशर होता है. वो प्रेशर काय पे होता है? आर्टरीज पे. हियर यू कैन सी, इसके अंदर से ब्लड जाएगा, तो जब तेजी से जाएगा तो वो उसकी आर्टरी पे क्या करेगा? प्रेशर डालेगा. ये प्रेशर हम नापते हैं, ब्लड प्रेशर. ब्लड प्रेशर, तो प्रेशर काय पे है? हाथ में जो आर्टरी होती है जिसके ऊपर ब्लड प्रेशर को नापा जाता है. उसी वक्त पैर में लेंगे तो प्रेशर अलग आएगा, गले में लेंगे तो अलग आएगा, बिकॉज सब जगह वो प्रेशर अलग अलग होता है. तो जैसे ही हार्ट पंप करता है, दबता है, कॉन्ट्रैक्ट होता है, तो प्रेशर ज़्यादा होता है, और जब वो रिलैक्स होता है तो प्रेशर कम होता है. तो यही कॉन्ट्रैक्ट और रिलैक्सेशन ही एक तरीके का प्रेशर डिफरेंस क्रिएट करता है. ओके, ये समझ में आ गया या नहीं आया?
आ गया.
हरी, यू गॉट दिस?
Yes, sir.
Okay. So whenever the blood is coming in this pipe में भी what you do, आपको जब पानी को दूर तक फेंकना है तो what you do? You just press the mouth of the pipe, and now the water can go more further. So it is like that only. In your heart also, you have to be very careful. This artery should not get blocked. because if it is getting blocked, the blood will not go this side. So heart has to pump that blood faster or harder. So that will be creating more workload on your heart, and that's how the heart attacks come up. Now let's see the pressure. In this example, you can find the pressure exerted by the sole of the shoes on the floor. It is the body weight resting on the shoes divided by the surface area between the sole of the shoes and floor. So here you can see where you will get more pressure. Hold on, read this. I'm just taking the phone. Hello. Good morning, Mata. तो कर दे पर क्लास लेते थे हमारे सर भी बता दो बताओ in which example you will get more hurt Hari
Sir,
yeah this shoes or sandal you will get more hurt or injury
the sandal,
why
because it will be different. Sir. Shoe will
what
be
different
comfortable for us, sir, but
huh?
sandals,
सैंडल का सरफेस एरिया कम है सर,
हाँ,
और
तो
शूज़ का ज़्यादा है।
हाँ तो प्रेशर ज्यादा पड़ेगा so this
यस सर।
example you can see this is the surface area that is coming in contact and shoes it will be so big areas coming. So there's a smaller amount of surface area on the bottom of the spike heel as compared to the flat sole result in much larger amount of pressure exerted. Okay. Example one more. It is better to be stepped on by a woman wearing a spike heel or by same woman wearing a smooth court shoes. Okay. If a woman weight, let's say about इसका weight है 556 Newton. The force she is exerting, that is mg. Okay, the surface area of the heel is 4 centimeter square and the surface area of the court shoes, this is the court shoes, that is 175 centimeter square. So how much pressure is exerted by each shoes? So we will calculate 556 as you can see 4 centimeter square and 175 centimeter square. Now let's see the difference. The value is 139 Newton per centimeter और ये है only 3.8 Newton. So you can compare how much difference the pressure is. It is about 43 times more. Round off करेंगे तो 44 times more that shoes is going to put more pressure. Okay. So by wearing the heel, you can see the difference. If she's stepping with that heel and stepping with the shoes. So that is the difference. You can see the difference is there. And the man will get more injured wearing, if the girl is wearing heel shoes, heel, compared to the shoes. Okay, you got this? You understand this? What is this? Hari,
sir,
you got this? You understand this?
it's the summer, sir.
Eh?
It's the summer, sir.
What? Some?
I'm seeing pressure. I got.
You got this, no? That we are calculating if the 4 centimeter is there, pressure is this much. If the shoes is flat, court shoes, we can say it will having more surface area. So that's why both the pressure, and when we compare both the pressure, we are seeing that by this is 139 and this is only 3. So how much more it is? That
40.
is 43.75. That means about 44 times more pressure. Okay,
Okay, sir.
so that's all for today. Tomorrow we'll continue with the pressure. You understand this example also, which I have given you in the artery,
Yes, sir.
है ना?
Yes, sir.
जब भी हार्ट पंप करेगा तो वो हार्ट क्या करेगा, प्रेशर डालेगा. आपने देखा होगा ना, on the when you are putting water in the garden, the pipe is flat. As the water flow through that, the pipe become expanded. Or if you are putting your finger at the mouth of the pipe, what will happen? It will try to come out from somewhere. और जहाँ आपने नल लगाया वहां से निकल जाएगा पाइप. So because pumping is there, continuous water is coming, so it has to go somewhere. So your arteries are, if it is okay to bear that load, it will be there. Otherwise, the brain hemorrhage is what? The arteries in the brain, they just cannot handle this pressure and they start bleeding. That's why the word brain hemorrhage is there. Hemorrhage is what? Injury to the arteries or vein. So due to the blood pressure only, because you are taking more stress, you are going to get injury to the arteries or vein. Basically, artery only, because in vein the pressure is not that much compared to the artery. Artery is having more pressure compared to the veins. Okay?
Yes, sir.
Okay, then tomorrow we'll meet. If tomorrow is what? Thursday?
Yes,
Yes,
sir.
sir.
Okay, so tomorrow I'll take class, but day after tomorrow, Friday, I'll not take your class.
Okay, sir.
Okay, sir.
Okay, then. Bye.
Okay. Thank you.
Thank you, sir.